Video number 3. Do this row of 4 problems for me, please. Freeze the video and do these 4 and then turn me back on. Okay, so 2 times 3 is 6. Square root is 75. 75 you break up into 25 and 3. 25 is a perfect square. 6 times 5 is 30, so it'd be 30 square root of 3. This one, square. There's no sum or difference, no plus or minus here, so I just square both terms. 2 squared is 4. Square root squared is reversed, so they get rid of each other, so it's just 5. So it'd be 20. So this one, whenever you're working with an index, you divide the power by that. So 6 divided by 3 is 2. 13 isn't divisible by it, so I break it up to y to the 12th y. 12 is, so it'd be y to the 4th, and then you have a square root of y left over. Same here. So this I would break up into x to the 20, y to the 15th, square root of x to the 4th. Stop biting me, Trixie. Goodness. So y, sorry about that, y squared. So I already fed you. So x to the 4th, y cubed, and then you have the 5th root of x to the 4th y squared. Now this, still radicals ending it here. You take this, distribute it to both terms, so it'd be 2 square root of 20 plus 2 times the square root of 4. 20 we break up into square root of 4, square root of 5. Square root of 4 is 2. Square root of 4 is 2, so it'd be 2 times 2 is 4, square root of 5 plus 4. This one, distribute 3 and 3 is 9. 3 square root of 5 minus 3 square root of 5 is 0. So that's gone. Square root of 5 times the negative square root of 5 would be negative square root of 25. Square root of 25 is 5. 9 minus 5 is 4. Now these are challenging problems. Rationalize the denominator. So you multiply the top and bottom by square root of 2. So it'd be square root of 2 over square root of 4, which is 2. Here you multiply by 4 plus square root of 2. So you'd have 4 plus square root of 2 over 16 minus 2. 4 minus 4 square root of 2, 4 square root of 2 is 0. It drops out. Minus square root of 2 times square root of 2 is minus square root of 4, which is 2. So it'd be 4 plus square root of 2 over 14. Woohoo! Now, I put way too many imaginary number problems on this review. There's only 3 of them on the final, but I did it. Square root of negative 1, start over. Square root of negative 9, 3i. This would be 5i. This is, break it up, square root of 4, square root of negative 1, square root of 5. So it's 2i square root of 5. Woohoo! Now this, most people get wrong. You cannot go negative 9 times negative 25 because they're not real numbers when you put them under the square root. So you got to pop your eye out. Pop your eye out. So this would be 15i squared, but we all know I squared is negative 1. So this, 2i plus 4i, 6i. Here, 3 minus 6, 4i minus a minus 5i would be 4i plus 5i is 9i. So we're going to do this, my peeps. Well, let's do this. 3i times 6 is 18i minus 15 I squared, but I squared is -1 minus a minus is plus. Should have 15 plus 18i. So let's see. Why don't you freeze the video and do all these problems for me, please? This is pretty fresh. Then turn me back on. Okay, FOIL. 2 times 2 is 4. 6i minus 8i is minus 2i. 3i times a negative 4i would be minus 12i squared. But I squared is -1. Minus is plus. So it's 16 minus 2i. 2i squared is 4i squared. So it'd be -4. Write it twice to make it nice. So it'd be 2 and 2 is 4. 6i is 12i. 3i and 3i is 9i squared. But I squared is -1. So it's 4 minus 9 is -5. So this one you multiply top and bottom by I. So it'd be I over 3i squared, which is -3. So this you multiply by the conjugate. So 12 minus 6i over 4 minus I squared. But I squared is -1, so it'd be 4 plus 1, which is 5. So this would be 3 plus 2i, 3 plus 2i. Distribute, that's 12 plus 8i over 9 minus 4i squared. But I squared is -1, minus is plus, all over 13. Yes. Now these two will not be on the final. I don't think. Let me check. I don't think. Nope. There's 3 questions on imaginary numbers. But this would be I to the 16th I squared. I to the 16th is 1. I squared is -1. I to the 27th would be I to the 24th. I cubed. So it'd be -I. This is 1. This is -I. If you memorize that like I told you. We're done with page 1. Only 4 pages to go on the final. But I can about guarantee it's going to be a lot faster than that was. Anyways, bye-bye.